Hello, in this video I'm going to explain the OAuth 2.0 authorization code flow by walking through a sequence diagram that I drew up step by step. And this is one of the most commonly used authorization flows on the internet today, and it's used whenever you click buttons like sign in with Google, log in with Microsoft, or continue with GitHub. And although OAuth is commonly associated with logging in, it's important to understand that OAuth is not actually an authentication protocol. OAuth is an authorization framework, meaning its primary purpose is to allow one application to access resources on behalf of a user without ever learning the user's password. And authentication verifies who you are as an identity, while authorization, which is what OAuth is, determines what you can do as permissions. And the authorization code flow is considered the most secure OAuth flow for traditional web applications because sensitive credentials and tokens never pass through the user's browser after authorization has completed. So let's now examine how exactly this happens. And before looking at the steps and all the arrows, I want to identify the 5 actors involved. First, we have the user who wants to access an application. And then we have the browser, or sometimes called the user agent. But it's exactly as it sounds. This is stuff like Chrome, Firefox, Microsoft Edge, Safari, whichever browser the user is using. And the third actor here is the site, your site, also called the OAuth client. And this is a web application the user actually wants to see. And next is the authorization server, of course. This is responsible for authenticating the user and asking for their consent, and then issuing authorization codes and access tokens. And our fifth and final actor here, we have the resource server, which stores the protected user data such as profile information, emails, calendar events, and files. And one important thing to remember is that the authorization server and resource server can be separate systems or apps, or operated and performed on the same provider or app. Now, let's follow the flow from top to bottom step by step. All right, let's go to step 1, which is very straightforward. The user clicks the button login with OAuth, and at this point, nothing security related has happened yet. The app simply begins the OAuth authorization process. Let's go to step 2. Step 2 is the authorization request. Now the browser sends a request to the authorization server, and in the URL, there are several important parameters. And first is a response type equals code, which tells that the authorization server we're using is an auth code flow rather than another OAuth flow. And next, there's going to be client ID, which uniquely identifies our application. Just think of it like a username for the application itself. And next, really importantly, there is a redirect URI, which tells the authorization server exactly where it should send the browser after authorization is complete. And then there's going to be a state parameter, which is a randomly generated value created by the client before the request is sent. And later when the auth server redirects the browser back, which is a later step, the client checks that the return state matches the original value. And if the value doesn't match, the request is rejected, which protects people against CSRF attacks or cross-site request forgery attacks, which I have touched upon in another demo. Finally, there's going to be a scope parameter, which defines what permissions the app is requesting. And an app may request access only to the user's profile information, email address, or calendar, instead of requesting unrestricted access. And that follows the security principle of least privilege. All right, let's move on. Step 3 is user authentication, where the auth server now returns the login page back to the browser. And the login page comes directly from the authorization server instead of our application. And what that means is that the user's username and password are entered only into the auth server and not the accessing application. And that is one of OAuth's biggest security advantages. All right, let's move on to step 4, which is users grant consent, where the user now enters their credential and approves the requested permissions. And at this point, the auth server has successfully already authenticated the user. And only after successful authentication and user consent does OAuth continue. Step 5, we have authorization response, which is where the authorization server now sends a HTTP 302 redirect. And instead of sending an access token immediately, it will return something called an authorization code. And this code will intentionally be short-lived, which expires within only a few minutes and can only be used once. Typically, it doesn't have to be. Even if someone intercepted the auth code later, it would already be expired or already have been redeemed, which adds a layer of protection. And the auth server also returns the original state parameter back to the browser. And the client later compares this returned state with the value it originally generated, and if they don't match, as mentioned before, the authorization attempt will be rejected immediately. And the next step is where the browser redirects back to the client. Now, it sends a request to the client application containing the gotten auth code and the state value. And this step deserves special attention because this is actually where many OAuth implementation mistakes occur. I've actually highlighted this step with a warning where redirect URIs exist here. And if an application accepts arbitrary redirect URIs or performs weak validation or fails to verify that the redirect URI exactly matches a registered value, an attacker may be able to steal authorization codes. And similarly, if the client fails to validate the returned state parameter, an attacker may be able to perform CSRF attacks by injecting their own auth response into another user's browser. So although OAuth itself is secure, an incorrect implementation of this redirect step is one of the most common causes of OAuth vulnerabilities. All right, let's go to token request, which is step 7. Now, this is a really important security boundary where the browser is no longer being involved anymore. And instead, this is the first time that the client communicates directly with the auth server. And this is called a server-to-server HTTPS connection, where the client sends a post request, which contains the auth code, redirect URI, client ID, and the client secret. And the client secret is basically acting like the application's password. And because this communication happens entirely between servers, the client secret never appears inside the user's browser. It should never do that. Likewise, JavaScript running inside the browser can't read or modify this communication at all. And this server-to-server exchange is one of the primary reasons why the authorization code flow is considered highly secure. Moving on to step 8, you have token response from the auth server back to the site. And if everything checks out properly, the auth server will return an access token. And depending on the implementation, it can optionally return a refresh token, which is exactly what it sounds like, a token that refreshes access and an expiration time. And the access token is essentially a temporary permission slip, which allows a client app to access protected resources without repeatedly asking the user to log in every single time. And the refresh token allows a client to obtain a new access token later without requiring the user to authenticate again. And this entire token exchange never touches a browser, which is a key security boundary of the authorization code flow. All right, and this is the info for it. Never touches browser, just to stress how important it is. Going on to step 9, we have the accessing protected resources, where now that the client possesses a valid access token, it can contact the resource server that has all the protected resources. And the client sends an access token inside the HTTP authorization header using something called a bearer authentication scheme, where if the token is valid and has the required permissions, the resource server authorizes the request. And second last step, there's protecting resource responses from the resource server to the site, where depending on the requested scope, the resource server now returns a requested user information containing perhaps the user's name, email address, profile pic files, or other selected protected data that the user gave consent for. And importantly, the resource server trusts the access token, not the browser. And that's another core OAuth principle. And the last and final step, we have the render logged in dashboard. And finally, the client application renders a logged in dashboard back to the browser. And from the user's perspective, they've simply logged into an application. But behind the scenes, 11 separate interactions have occurred between multiple systems instantaneously, basically, to ensure that the authorization happened securely. And as a conclusion, let's talk about why this flow is so secure. First, the user's passwords entered only through the OAuth server, and then the access tokens never delivered directly through the browser so that attackers can't look at the browser and get any important information out. And third, the client secret is never exposed to the user, and authorization codes are short-lived and single-use so that if an attacker gets to somehow have a hold of that, it is short-lived and single-use, so it might already be expired or they can't use it after a bit. And also, the state parameter protects against CSRF attacks. And finally, the token request and token response takes place entirely over a secure server-to-server connection. And altogether, all these mechanisms significantly reduce the attack surface, if implemented properly. And one of the key reasons why I did highlight step 6 with this redirect URI vulnerability is because these OAuth vulnerabilities usually don't come from flaws in the protocol itself for OAuth, and they, again, arise from slightly incorrect implementations that didn't follow the rulebook. And for example, failing to validate the redirect URI, not verifying the state parameter, or accepting auth responses that were never initiated by the app, makes it so that attackers can inject auth codes and perform login attacks, or trick users into authorizing actions that they never intended. And understanding this boundary is so useful when analyzing OAuth attacks, because almost every real-world OAuth vulnerability does target mistakes around the authorization response rather than the weakness in the protocol itself. The protocol is quite rigid and good. So yeah, to summarize, the OAuth 2.0 auth code flow separates authentication from authorization while keeping sensitive credentials away from the client app. And the browser is only responsible for transporting the user through the whole process. The auth server authenticates the user. The client exchanges the auth code for tokens over secure server-to-server connections. And the resource server trusts those tokens to determine whether protected resources should be released or not. And understanding every single interaction here is so important because it detailedly explains how OAuth works and why specific implementation details, such as redirect URI validation, are so important for preventing security vulnerabilities. All right, that's it. Thank you for watching.